Good morning, everyone. Just see there's a couple more people registering. So it's 10 o'clock. Hope everyone's keeping well. Welcome to our 7th Focus on Food webinar. Today's webinar will be focusing on food allergen testing. So in today's presentation, I'll provide a brief overview of food allergens, explain the regulatory context, look at allergen management and allergen control plans, look at ingredients testing, cleaning validation and end product allergen testing, cover allergen swabbing, how to pack and send your samples, what do your results mean, and we'll wrap up by covering some of the FAQs and issues that we get around food allergen testing. The purpose of the webinar is to provide actionable information and tips for you to take forward into your own business, help you remain compliant, and to help make your testing more cost-effective in the long term. A food allergen is defined by the Allergen Bureau as a naturally occurring protein that causes an abnormal reaction in affected people. People can have an allergic reaction to almost any food, but the most common are egg, cow's milk, peanuts, tree nuts, which are almonds, walnuts, and pistachios, etc. Soy, wheat, crustacea, fish, sesame, and lupin. These allergens are responsible for over 90% of food allergies worldwide, which is why the regulations require them to be declared when present in a food. It's important to understand the difference between a food allergy and an intolerance or a sensitivity, as one has the potential to cause severe injury or even kill consumers, and the other generally produces mild or chronic reactions. I like to think of it this way: a food allergy involves the immune system, and an intolerance or a sensitivity involves the digestive system. The symptoms of a food allergy can become obvious very quickly, sometimes just through contact with someone else who's eaten the food that they might be allergic to. Mild to moderate symptoms include swelling, welts, abdominal pain. The body's immune system's reacting to what it perceives to be an attack by a foreign invader. So this reaction can be very fast and quite unsettling to experience. Symptoms of a severe allergic reaction can be extremely harrowing for those who experience or witness them. Known as anaphylaxis, these reactions can quickly become life-threatening, which is why those who are particularly affected by strong allergic reactions often carry with them an epinephrine, which is an adrenaline autoinjector, commonly known as an EpiPen. The Australasian Society of Clinical Immunology and Allergy, ASCIA, states that food allergies occur in around 10% of infants, 4 to 8% of children, and about 2% of adults in Australia and New Zealand. In 2016, a French teenager, Natasha Ednan-Laperouse, on the left, tragically died on a flight from the UK to France after buying a pre-packed sandwich at the airport and having a severe allergic reaction to the undeclared sesame in the bun. The company that supplied the sandwich, called Pret-a-Manger, were subsequently at the center of another death due to undeclared allergens when a 42-year-old mother, Celia Marsh, on the right, died in 2017. She had an allergic reaction to an undeclared milk in her sandwich, which contained dairy-free yogurt. These two cases, less than a year apart, severely affected the company and highlighted the difficulties in both managing the supply chain and applying labeling that not only complies to the regulations, but keeps customers safe. The cases are ongoing in terms of legal ramifications, and there looks certain to be some regulatory changes to the UK's food laws that could potentially spill out to other nations and states in the coming years. Obviously, with challenges come opportunity, and this is increasingly the case with the allergen space. The free-from category is estimated to be worth around $388 billion by 2024, with a compound annual growth rate estimated to be around 9.5% between 2019 and 2024. The gluten-free category alone is set to increase from $3.73 billion to $6.43 billion in the same period. And growth's being driven obviously not only by increasing numbers of people with food allergies, but by people making lifestyle choices and seeking clean label products. Here in Australia, allergen labelling is addressed in the Food Standards Code through Standard 1.2.3, which is information requirements, warning statements, advisory statements, and declarations. This standard covers all warning statements, including those for royal jelly, added sulfites, sweeteners, and obviously the 10 most common food allergens, which are shown here on this graphic. The regulation states that if any of these foods or substances is present in a food for sale, a declaration that the food or substance is present is required. It further tells us that the labeling also applies if the food or substance is present as an ingredient or an ingredient of a compound ingredient, or as an additive or a processing aid. There are a few exemptions, and these include gluten-containing cereals in beer and spirits, and glucose syrups made from wheat starch that have been refined to remove the gluten or have a gluten content less than or equal to 20 milligrams per kilogram. In Australia, product recalls due to undeclared allergens significantly outstrip all other reasons for a recall, and approximately the same as the second and third reason combined, which is microbial and foreign matter contamination. Strongly recommend that you check out the FSAN's website for more information on allergen recalls, as there's a wealth of useful information on the site. Now, this particular table is taken from the page on recall statistics, which also goes into some really useful detail about the reasons for undeclared allergens being present. For example, this table shows the root cause for undeclared allergens as a percentage of the total. Obviously, you can see there that packaging errors account for 50% of last year's allergen recalls. With regard to undeclared allergen recalls, the prime offender is milk, which makes up about 30% of the total. Undeclared milks often associated with dairy-free yogurt products, or as a low-level detection in coconut milk or cream products. You may remember pre-COVID, earlier this year we had a nationwide recall of multiple brands of pesto products here in Australia, which affected the shelves of Coles, Woolies, Aldi and IGA all stores. The issue wasn't restricted to Australia. Extensive recalls took place in Europe and UK prior to Australia. The global recall arose from a batch of cashew nuts used in pesto manufacturing in Italy. They were found to be contaminated with trace amounts of peanut. So when testing for the presence of peanut in a cashew containing product, a test kit would need to be able to differentiate very low levels of peanut against a background of cashew, which demonstrates how sensitive these testing kits need to be to keep people safe. Allergen management is the overarching set of policies, procedures, and processes in a food business that work together to control allergens in a company. Like HACCP, it requires senior management commitment, systematic planning, and rigorous implementation. You can't leave anything to chance. A written allergen management plan contributes towards demonstrating due diligence. It helps staff and suppliers understand their role and provides documented procedures to follow in the event of an issue. Obviously, it's a legal requirement to have a recall action plan, with up-to-date information on local authority contacts and obviously contacts within your business. It should be part of your allergen management plan, and training in what to do and how to avoid the pitfalls should be communicated to all relevant staff involved. The allergen management plan itself should sit within the broader HACCP plan and take in prerequisite programs, operate in line with good manufacturing practices. Like HACCP, allergen management is based on risk management, which starts with a risk assessment. I've mentioned the Allergen Bureau previously in this presentation. They have some really useful resources on their website that can help you with your risk assessment process, even if you're not a member. Please check out their website if you haven't already done so. The Allergen Bureau has worked with the FSANs on allergen communication and is a recognized global leader in allergen management tools and information. You may have heard of the VITAL program, which stands for Voluntary Incidental Trace Allergen Labeling. This was launched in 2007 as a tool for the food industry in Australia and New Zealand, and is now in its third iteration, VITAL 3.0. VITAL includes the precautionary statement may be present in relation to the potential for cross-contact allergen presence in a product. This is a defined level of risk based upon scientific principles. It's not that you see the catch-all of may contain. Now, the risk review site is part of the Allergen Bureau website, and it contains some excellent pointers for conducting your allergen risk assessments. The graphic here has clickable links which take you to additional information. Here's the link for that particular risk assessment page. Obviously, your risk assessment will inform which controls and activities are in your allergen management plan. So the allergen management plan is a key document in your food safety program. Like HACCP or a food safety plan, it has to be site specific, as each facility and process bring their own risks and issues. Most allergens are brought into your facility through the purchase of raw ingredients, which is why it's crucial to know the allergen status of all your raw ingredients. When purchasing, you should obtain ingredients with a certificate of analysis showing that they are allergen-free if you require allergen-free ingredients. Check the dates on the certificates of analysis. Do they relate to the batch from which your ingredients come? Are they current and relevant? Bear in mind also that it's much easier to detect allergens in raw ingredients than end products, as the manufacturing process can make certain allergens undetectable in the final product, whilst not negating their ability to cause a reaction in the consumer. What form are the allergens present in at your facility? Are they powder, liquid, chunks, pieces, etc.? What amounts are likely to be present? Ensure you've considered cross-contact and have detailed all of the control measures to reduce the potential for or avoid altogether cross-contact within the facility. Has it been adequately trained out to all staff? Are your SSOPs validated? We'll go into this in a bit more detail later. How do you handle rework materials to stop the potential for contaminating subsequent products and batches? How do you label your waste and rework to keep them separated? Are you able to adequately keep everything separated? And how's each employee trained about their role in allergen management? Consider implementing an approved supplier program if you don't already have one. An approved supplier program goes a long way to ensuring that you have full confidence in your ingredient suppliers. You need accurate allergen information from them. Shouldn't be afraid to ask questions if there are gaps in the information or you're not sure about anything that's supplied. Ensure that your supplier is knowledgeable about the allergens in their products and any potential cross-contamination issues. Pay particular attention to changes in supply of a particular ingredient. Ensure that you're informed of any changes to the allergenic status in advance of receiving the materials, because you need to be able to separate them out once they get into your facility. Consider developing a supplier questionnaire. It doesn't have to be long and complex, or just conducting an audit to ensure that you're confident in their ability to identify all allergen risks from their products. So testing should always be informed by strategy and produce actionable outcomes, i.e. testing should be part of a process, not an end in itself. Used properly, testing is a really effective and useful tool in your food safety arsenal. It can identify and or quantify the presence of a food allergen at a particular point in the production process, which will provide valuable information only if the results viewed in the context of an allergen management plan. There are limits to what testing can do on its own. For example, a single test in the absence of a robust allergen management plan can't really guarantee that a product is free from a specific allergen for which it's at risk. Now, testing can be complex, variable, and sometimes it can be frustrating. But when utilized with an appropriate risk-based sampling plan, it can provide valuable feedback on your controls and processes. For in-process or post-cleaning testing at your facility, there are 3 options if you wish to perform the testing in-house. Firstly, there are ATP swabs. They're the most basic. Some of you may use them for post-cleaning verification, sanitization effectiveness. Basically, these swabs pick up traces of ATP, which is adenosine triphosphate. It's an organic compound that's found in all forms of life, so animals, vegetables, microbes, and food protein residue. It's important to know that these swabs are not able to differentiate between any of the life forms. So they've limited use testing for allergen residue on a piece of equipment, for example. Next, you have a protein swab kit, which again, you probably use post-cleaning. It has the same advantages and disadvantages really as the ATP method. It's just a slightly different process. It works on a color basis. If it's green, it's okay. And then darker levels indicate the presence of more protein. And finally, in this section, we have the lateral flow technology. This is a low cost, easy to run and use, fast turnaround technology. It can be run anywhere. It's popular for in-house testing. But some of the disadvantages of this technology are the high rates of cross-contamination. It only gives you qualitative results, i.e. presence absence, so there are no counts. It's particularly subject to false negatives if it comes into contact with material with very high levels of allergen content. And obviously it can only be run on swabs, so it's not suited for end product testing. Laboratory options, 3 main analysis methods globally for testing for allergens. Firstly, ELISA. This stands for enzyme-linked immunosorbent assay. They're testing kits that are the current method used by labs for allergen testing here in Australia. Kits focus on marker proteins, and they're very specific, and therefore very few false positives. They're also quantitative, which means that they can provide numbers for allergen concentration, which helps when conducting your risk assessments for vital or for your allergen management plan. These kits are also very good at detecting low levels of allergen, which is used for identifying potential cross-contact issues. Next, we have liquid chromatography mass spectrometry. This is an emerging method that identifies peptide markers from the target protein. It's capable of differentiating between several closely related proteins, and is also effective in detecting allergenic proteins that have been broken down during processing. Disadvantages are the high levels of training and skills that are required to use the technology, also very high initial setup costs and for running the tests. There's also a lack of complete protein libraries as well, which is sort of holding back the technology globally. Finally, PCR, polymerase chain reaction, is a method that detects DNA sequences of the allergic species rather than the specific protein. The advantage is that this method can detect more than 2 allergens at once. It's more reliable than ELISA in highly processed matrices. But the main limitations with this method are, again, really high initial setup costs for the technology, around $250,000 for the equipment, and it can't be used for products containing animal DNA if you're looking for an allergen from that animal. For example, milk with cow present, or egg with chicken present, because it'll just pick up the chicken. It's therefore not routinely used in Australia, except as an alternative method when interference denatures the proteins or biomarkers. So here are a few pointers you should be considering when choosing your allergen testing method. Is the method externally validated for what you need it to do? There are lots of kits on the market, and the one that's chosen needs to be able to provide the information that you're actually seeking. So it's really important to speak to the laboratory or the analyst and tell them exactly what you need. Don't leave anything to chance or make assumptions. Also, when comparing labs, which is good to do, it's important to be comparing apples with apples, like with like. Some methods are validated for certain matrices and not appropriate for others. Secondly, is the limit on the test sufficient for your requirements? For example, if you're making a gluten-free claim, your product must not contain any detectable gluten. Now, if you're using a method with the lowest, if you're not using a method with the lowest limit of quantitation, you risk not being compliant with the regulations. Thirdly, will the chosen method provide you with the information you need? Choosing a fast and cheap method may not provide you with actionable results. You need quantitative data to verify a vital risk assessment. You shouldn't choose rapid methods for that. Fourth, the importance of talking to the analyst or laboratory before testing can't really be stressed highly enough. Some test kits will not identify a specific allergen in a particular matrix because of interference or for some other reason. If the lab knows what's in your product, they can choose the kit that's most appropriate. Similarly, some kits are not produced for the Australian market and will give false negatives when used. So it's really important to go with a lab that has the experience and knows which testing kits to use. And again, it's about knowing where your ingredients have come from and any particular treatments that they may have had in other countries before being imported. Finally, obviously, cost plays a part in deciding which methods used. Some of the analyses mentioned earlier require huge investments in technology, and the available market just doesn't support or justify running those analyses. So testing your raw ingredients to ensure they comply with specification is good practice, and it will provide you with assurance that your ingredients are what you're expecting. There's a fantastic resource available on the Allergen Bureau website called Unexpected Allergens in Food. And it provides a list of common ingredients that can pack an allergen surprise. A couple of examples, things to look out for. Baking powder, does it contain carriers or bases such as wheat flour? And secondly, coconut milk or coconut milk powder sometimes contains casein, which is a milk protein. There are hundreds of examples of ingredients that contain unexpected allergens, and I strongly recommend you download and use that resource from the Allergen Bureau website. It's available at that link there. And I will also upload a copy to the Focus on Food website after this webinar. So as I alluded to earlier, the easiest tests to undertake are non-specific protein swab detection kits. Because they're non-specific, however, their usefulness is limited to verifying the broad effectiveness of clean-in-place procedures or monitoring food contact services post-cleaning. They don't distinguish between allergenic and non-allergenic proteins. And ATP tests are even less specific. They just detect the presence of organic materials. So their use is limited to cleaning verification only, really, and shouldn't be used exclusively for allergen testing post-cleaning. The most effective way to validate your cleaning and sanitization regime is through pre and post-cleaning swabbing, and then sending the samples off for testing at a lab. You need to know, firstly, that the allergen's present in order to verify after cleaning that it's been removed. So ensure that the allergen is detectable by swabbing before you clean. Consider using a carrier allergen if your target allergen is likely to be affected by processing. For example, if you have a product that contains soy and wheat, then test for wheat. The soy protein is not only very difficult to detect, but it also breaks down really easily under heat and changes to pH. One of the biggest issues we see with end product testing for allergens is the effect of processing. Increased temperatures, changes to pH can alter the structure of the proteins and make them more difficult to detect. However, although they are more difficult to detect, processing can actually increase the allergenicity of the proteins, which makes them more harmful to people with allergies. Some raw ingredients can cause interference with the accuracy of the testing, particularly those containing polyphenols, which are, for example, blueberries, cabbage, blackberries, and onions. If any of these are present in your end product, you should tell the lab, as they'll need to perform specialized extraction protocols to achieve most reliable results. End products also, may only have small amounts of allergen in them, especially if it's from cross-contact following an ineffective clean. The presence of cleaning agents can also impact testing in a negative way. When using swabs for allergen testing later at the lab, it's important to use the correct swabs and to store them correctly. ALS recommends using swabs with no media and no water, and to keep the swabs refrigerated between 2 and 8 degrees centigrade before sending them off. Never freeze the swabs or allow them to get wet. So we often get asked whether it's good practice to composite samples of end product or raw ingredients when testing for allergens. Compositing samples just means taking random samples from multiple batches and sources and combining them into one larger sample for submission to the lab. I asked Carl, our lab manager, whether he recommended composite sampling for allergen analysis. There you have it. Avoid composite sampling for allergen analysis. Testing a composite sample may dilute the true allergen concentration and lead to reporting a value that's not representative of the true level of allergen in any of the individual samples that were composited. When testing for the presence of gluten, you need to know that it clumps together, it doesn't completely disperse around the product. The only way to effectively sample for the presence of allergens in your end product is to use a risk-based sampling approach. For example, take samples from different time points within a batch or from multiple batches or runs. So remember that one test proves nothing, and don't rely on end product testing alone to verify that there has been no cross-contact. As with HACCP, testing is used to verify that the processes and controls are effective, and an appropriate number of tests need to be undertaken in order to verify this. Please ensure that all samples are packed correctly easily identified and kept refrigerated prior to sending to the lab for testing. This is crucial. For end product allergen testing, it's really important to also include an ingredients list for the product and information about the processes that it's been subjected to. By doing this, our analysts can ensure that the most appropriate method and testing kit for the target allergens used. You can record information about your process and ingredients on the sample submission form. There's space there. When you registered for this webinar, you're also hopefully provided with free access to our Focus on Food support website, which has a number of videos that can help you when packing, sending your samples off and filling in your sample submission form. They're available at that link. So some common issues. Some of the most common we get in relation to allergen testing are fairly easily avoidable or explainable. Number one, as we previously mentioned, it's not providing correct information on a sample submission form. This may be contact details of the person who should get the certificate of analysis. It could be an old contact, somebody who's left the business. Always make sure everything's up to date. The sample names, the tests that are required, things like that, always double check the form. We receive thousands of test requests a day, and inaccurate forms may not be picked up until after testing is complete. Another common issue, particularly with allergen testing, is when there's an unexpected positive is communicated, that it's immediately assumed to be a lab error. Now, before the lab sends out a certificate of analysis with a positive allergen detection, a confirmation test and a process of ensuring that the test was accurate has already been undertaken. So asking the lab to do a retest probably won't change that result. Obviously, you know, occasionally mistakes happen, but not as often as people think. Also, be aware that if your samples were also tested in another lab, before comparing the results, you need to know whether both labs used the same methods. When you receive a positive detection for allergen in a product, you need to check your allergen management plan or refer to Vital 3.0. Obviously, not all positives require a recall. When asking for urgent testing, please try to speak to the lab at least 24 hours in advance to confirm whether they're able to do an urgent turnaround or not. Allergen testing is batched, and this helps obviously to keep prices down for clients. It makes it more efficient for us to run them. Allergen tests that have higher throughputs have lowest turnaround times, obviously, because they're able to be run more often. So, for example, gluten, something that we do on a daily basis, whereas something like beta-lactoglobulin has a 7-day turnaround. So easily the least common test that we perform. Critically important for you to provide supporting information to the lab when sending in samples for allergen detection, as this will help the analyst select the right kit and interpret the results effectively to provide you with the best information that you need. Don't send your samples to any lab if you haven't discussed your needs in advance. There are many variables that can have an impact on detecting the target allergenic material. You also need to have confidence that the analyst is experienced enough to give you the best information available. Finally, when packing samples, swabs and samples themselves should be kept chilled at between 2 to 8 degrees centigrade. Never freeze samples that require allergen testing. So just want to end by briefly covering some of the information that you get with your results and looking at what the results can mean. When you receive your results, they'll come in the form of a certificate of analysis, or COA. This is a formal document signed by approved personnel that have been trained to NATA requirements to ensure the highest standards. The certificate of analysis will have the name and address of the client at the top and will be for the attention of a specific person. So just ensure that this person has the necessary experience to read and understand the results. The next part of the report provides the name of the sample, the reference number for the sample if you need to discuss it further with the lab, and the dates that the sample was received, when testing commenced, and when the results were released. You'll also see a section marked your reference, and this refers back to the name you gave the sample on your sample submission form, which is why you need to make the information on the submission form meaningful for you. Next comes the main part of the certificate, the results. You will see down the left-hand side the reference numbers for the methods applied to your sample. Then the name of the method in the second column, for example, peanut residue. In the third column are your results. You'll ideally want to see ND there, that means not detected. If you see a number, for example 7, just check whether it has a less than sign in front of it. For example, you'll see sometimes less than 3 for gluten. This usually means that the allergen was detected, but at a level below the limit of quantitation for the method. Now, with a sensitive test, there may also be a greater than result if the allergen was detected at levels above the limit of quantitation. For example, in the sample certificate, you can see that almond was detected at levels greater than 25 milligrams per kilogram, which was the limit of quantitation for this particular method. Some methods will not give you a number, just a detected or not detected. So you need to ensure that you're choosing the correct method. If you need a number, if you need to know the levels present, then you need a method that can give you that. In column 4, we see the units that the results are presented in. This is crucial information. Milligrams per kilogram is the same as parts per million, so you'll see some labs may present it as parts per million. You also notice that for walnut residue and peanut residue, here we've got the result states milligram per kilogram of total walnut and total peanut. Now this is different to milligrams per kilogram of peanut protein or walnut protein. So these are important differentiations, and you'd need to speak to the lab if you're not sure about these when they come back. For example, 4 milligrams per kilogram of total peanut protein would be equivalent to 1 milligram per kilogram of total peanut. So it's really important to be aware of this when you get your results, because it can make quite a difference. At the bottom of your report, you'll see the name of the signatories and their position and role. Most labs also add comments underneath all the technical information, and these will explain which methods were used. They'll let you know the kit that was used and the associated limit of detection or limit of quantitation, so that you can compare different results from different labs and know that they are comparable. Ask for the lab to put on your report the test kit that was used and with the stated limit of quantitation. If you're comparing different lab results, only compare apples with apples. There are labs and kits out there that are using different limits of quantitations because they're using different kits. You may remember from a previous webinar that we did that limit of detection refers to the lowest concentration of an analyte that is feasible using the particular method. So it's the lowest limit at which the presence of the analyte can be distinguished from the background noise of the sample. The limit of quantitation is the lowest concentration at which the analyte can not only be detected, but at which some predefined goals for bias and imprecision are made. So the limit of quantitation may be much higher than the limit of detection, and it's never lower. So that sort of brings us to the end of the presentation. I expect, and I can see that there are a few questions. Obviously, it's a large and complex subject, very topical at the moment. So if you do have questions, and we don't really have a lot of spare time in the webinar at the moment, but here's my email address. If any of you have any questions about allergen testing, writing allergen management plans in general, or anything else that's come up during the presentation, please send them to me at this email address. I promise I'll answer every single question. Just be patient if I don't get back to you immediately. I'm expecting a few. I also have our own allergen testing specialist, Carl Cusco, who's the food chemistry lab manager at our site in Scoresby, and he's on standby to help with any the complex technical testing questions. Carl's a recognized expert in this field, and he's responsible for most of the technical insight in this presentation relating to testing. So he's a fantastic source of information, really helpful to me, certainly, in putting this information together for you. Just got a minute or so to tell you that in our next webinar, we'll be focusing on nutritional health claims, how to remain compliant. I'll be uploading the recording of this webinar to the Focus on Food website later today, where we also have recordings of all of our previous webinars. So if you've just registered, this is the first webinar that you've registered for and you want to check out some of the previous ones, they're all there on the website. Thank you very much to everybody for attending today. It's been quite a large gathering, so thank you for that. I hope it was of use to you. Take care, and hope to see you all next time. Thank you very much.